So I mentioned it before. This idea of SOHCAHTOA as a way to help us remember our definitions. We've already learned that tan was the opposite over the adjacent. And so although we could do everything with tangent and a squared plus b squared equals c squared, sometimes it was just like, oh, it would be so much nicer if I could just do it directly. So having all the ratios allows us to not have to use a squared plus b squared equals c squared and just solve things directly. So we have our definition for sine, opposite over hypotenuse, and our definition for cosine, adjacent over hypotenuse. And I don't know how someone decided that sine should go first, then cosine, then tangent for saying SOHCAHTOA, because nobody learns katoso or toakaso. That actually sounds bad. Sounds like a swear in a different language or something. So everybody says SOHCAHTOA. I'm not sure why they decided on that order, but that is what we use, SOHCAHTOA. So when a question asks you to determine sine g and cos g, like this one, or sine whatever angle and cos whatever angle, they're just asking for the definition. The number one mistake students make in this question is they get so excited to solve for something, they actually solve for something. This one, you just have to write down the definition. Sine is opposite over the hypotenuse. So all we need to do is look at g. That's this angle down here. Which is the opposite side? Well, of g, the opposite side is 8. The hypotenuse, and you can, some people always like to label their hypotenuse right away. It's always opposite the 90 degrees, just so you don't accidentally mix it up with an adjacent side. So the hypotenuse is 17. And so your calculator would have an angle built in somewhere with that ratio. It says to the nearest hundredth, so we could go 8 divided by 17 just to find out what that answer is, 0.47. I like the fraction better, because as soon as I see the fraction, I imagine numbers on the triangle. With the actual decimal, I mean, you could change it to 47 out of 100 and then draw another triangle, but the actual fraction helps you draw a triangle right away. And same thing, change colors here. We could do cos. Cos of g, the definition would be adjacent over hypotenuse. So sine, cos, tan. And on our calculator, if we wanted to find out what that was as a decimal, 0.88. So we didn't have to solve for anything. We just had to use the definition to write out what was sine of angle g, what is cos of angle g. Okay? Ooh. If you want to see something cool, square this and add them together. 8 over 17 squared, 15 over 17 squared. Add them together and tell me what the answer is. Don't round early. Okay. And now we can use our calculator to determine and draw a picture to show what it means. So if we have sine of 30 degrees, this is sine's pretty angle. Sine has one pretty angle. This is its pretty angle. Sine of 30 degrees. Sine of 30 degrees equals, tan's pretty angle was 45. Sine's pretty angle is 30. And it's equal to 0.5, which as a fraction you could write as 1/2. So that means I could draw a picture of a triangle. I could label 30 degrees, and I know that the opposite side is 1 and the hypotenuse is 2. Or I could use 2 and 4. Or I could use 6 and 12. Anything that has a ratio of 1/2. In other words, for 30 degrees, you always have your hypotenuse double your opposite side.
So if you know the angle is 30, and then you know hypotenuse or opposite, you know the other.
That's right. So if I drew this triangle right here, and I knew this was 30, and I knew this distance was 12, I'd go, oh, this has to be 24. And it's true. Works every single time. For 30 degrees, and that's the one that's nice. Because your mental math can happen really quickly for 30 degrees. 15 degrees for cos, not so nice. If we go to cos 15 on our calculator, cos 15, 0.9659. Okay? So if I drew 15 degrees here, this as a fraction, I did a lot of decimal places here. That number as a fraction would equal 9659 over 10,000. So one possible triangle, 9659 over 10,000 is a possibility, depending on how I rounded. If I rounded 0.97, then 97 over 100 would be close. But these are all estimates because we had to round. With 30 degrees, it was already perfect.
So 15 degrees, that ratio would always be true?
With 15 degrees, that ratio would always be true. So if I drew a triangle here, and I made this 15 degrees, and I said this was 10, it's a little hard to get that ratio, right? Mental math doesn't help us. We would know, oh, it's a little bit more than 10. But we would have to use our calculator and our definition to say, if I want to find that, I know that cos of 15 degrees has to equal 10 over x. I'd have to multiply both sides by x. And then divide both sides by cos 15. Now, based on the pictures we have, it looks like, oh, this should just be a little bit more than 10, right? Based on the ratio of what the numbers are. If we go to our calculator and I do 10 divided by cos of 15, sure enough, it's 10.35. But mental math, we couldn't do that. Not like the 30-degree one where I put 12, and you're like, oh, it's double. It needs to be 24. So 45 degrees is the nice one for tan. 30 degrees is the nice one for cos. Or no, for sine. And I'm not telling you the nice one for cos. You got to figure that out on your own. But there is one nice one for cos. Hey, did anybody do 8 over 17 squared plus 15 over 17 squared and add them together? It equals 1. Nice. So we're going to get triangles, and things are going to be labeled. And this one says, determine the measures of angle K and angle M. So I'm going to color code things here. I'm going to circle K with green, and I'm going to circle M with blue. And in both cases, I'm going to label the 8 as my hypotenuse because it's opposite my 90-degree angle. So the 8 will always be the hypotenuse. Now I want to find K. And one of the things you're going to do, okay, you will probably write SOHCAHTOA at the top of every test that you do. And if I'm finding K, I know the hypotenuse. So on the green one, I know the hypotenuse. That already says, I should probably use sine or cosine. And if I look at angle K, what's the number 3 in relationship to the angle K? It's the opposite. So looking at SOHCAHTOA, I know the opposite, so I should put a check mark under here. With cos and tan, I only know one thing. But with sine, I know 2 of the things. And so the definition I'm going to use to figure out K is to use sine. The opposite side is 3. The adjacent side is 8. Now the step that you don't write, but you can if you want to, the next thing we do is we take, maybe I'll even show it. No, I'll do it right here. Sine inverse of this side and sine inverse of this side. Sine inverse and sine will cancel out because they're opposites of each other. And we just get K is equal to sine inverse of 3/8 and we go to our calculator, and since our calculator has all of those values built in, it says, if you have a ratio of 3/8, I know that the angle is 22.0 degrees. And we're supposed to round to the nearest tenth of a degree, so K is equal to 22.0 degrees. For angle M, we're going to find angle M next. There's 2 ways we can go about finding angle M. If you decided I would like to find angle M first, then you would say, hey, I know the hypotenuse. So I'll put blue check marks now over my hypotenuse. And thinking about M, the side that's labeled number 3, that's not the opposite side anymore. Now that's the adjacent side. And so I know the adjacent side. And looking at all my check marks in blue, it becomes obvious that I have to use cosine would be the best. So I write out my definition of cosine. Cos of angle M, that's not M looking. Cos of angle M is my adjacent side, which is 3, over my hypotenuse, which is 8. And angle M, if we take cos inverse of both sides, my calculator says, I have all my cos ratios memorized as well. You have a ratio of 3/8. I'll tell you that with the ratio of 3/8, the angle is 67.97, rounded to the nearest tenth, 68.0 degrees. Now I pretended I did the blue one first, so I could use SOHCAHTOA or trigonometry to find 68 degrees. But if you did figure out angle K was 22.0 degrees first, can you see another way that you could have figured out angle M was 68 degrees? The triangle adds up to 180. So once you find one angle, then you just have to add up to 180 to find the other one. Now that's probably even quicker, but really the cos and the sine stuff isn't very time consuming at all. It's just a matter of, do I know my definition? And if I'm solving for the angle, I have to get rid of the cos. The way I get rid of the cos is to do cos inverse of both sides. And then my calculator does the rest. Life is easy. Okay? I mean, I could make you say, no, you're only allowed a protractor and a ruler for this unit. So when you have a question like this, you have to measure out perfectly 3 centimeters, 8 centimeters, make a right angle, take out your protractor and measure the angle, which would be really hard to do to the nearest tenth. Okay? But possible. This is much better. One more question. So at a certain time, a float plane is 300 meters above the water and 430 meters from an observer. Okay? We need to draw a picture. So we have to draw our float plane. Ooh. I wonder if I could do this. This is going to be cheating if it works. Choose. No, I don't want to do the. Yeah, there it is. Yeah, perfect. Couldn't have drawn it better myself. So there is our float plane right there. It is 200 meters above the water. 300. Thank you. 300 meters above the water. There we go. There, perfect. So there we have our water and our person. Da-da-da-da-da. Our person is standing somewhere 430 meters away. So obviously, the person is not here. Blip, 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 blip. They have to be somewhere further away. Okay? Luckily, they're on an island. Now, where's that 430 meters going to be? Are we going to label the side or are we going to label the hypotenuse? Because from this person, I can make a triangle to the float plane and to the spot where it's directly above. Where am I going to label that 430 meters? Okay? If the plane is 430 meters away from the person, how do you measure distance? Right? If I was measuring my distance away from you, would I say, I'm this far away from you? Or would I measure it directly? Directly. So our 430 meters that's the direct distance away from the person to the plane. Determine the angle of elevation. Angle of elevation is from the horizontal, looking up, measured from the observer. So the angle we want to find is this one. SOHCAHTOA, which one should we use? Sine, cos, or tan? Sine. It's not a sin. It's not bad. It's trig. It's good. It's happy. Okay? Sine. We're going to use sine because we know the hypotenuse. That's the 430. And we know the opposite side. So with SOHCAHTOA, which one has the opposite and the hypotenuse? That's sine. Write out our definition, 300 over 430. And then we can figure out what the angle will be. Take the inverse of both sides. And go to our calculator. Are you okay if I write 30 over 43 instead? What did I do? I just reduced it by dividing them both by 10. Okay? Again, your calculator has it memorized. Your the angle is 44.2 to the nearest degree would be 44 degrees. Oh no. Okay, this is a crazy plane because it hit the water and exploded into flames, because that's what happens when planes hit water. I've seen it in movies. All right, so we had both with what we ended earlier and right now a few questions to practice.